Hi everyone, welcome back to the Sagar TechGate. In this video, we'll explore a gate level modeling in Verilog. One of the most fundamental ways to describe the digital circuits using a basic logic gates. This is where a digital circuit truly begins. We will write a Verilog code. The circuit represent real hardware behavior using a gates like AND or etc. And more just like building a circuit with actual components. Gate level modeling. So the model is implemented in terms of primitive logic gates and interconnection between these gates. So in gate level modeling, we'll use a basic gates known as a primitives. If you want to build any digital circuits, just we'll draw the diagram in terms of gates, and we are connecting those gates by using a whites. So the model is described by the logical links and their timing properties. So it resembles a schematic diagram with components connected with a signal. That means describing the design in terms of a gate level logic diagram. It is the lowest level of abstraction in Verilog. So it look like a simple hardware, okay, in terms of gates. So we are writing a Verilog code by using these gates, nothing but by instantiating these gate, connecting these gate, we build a model. We build a digital circuits. So now if we see this off order having a two inputs A, B and the two output sum and carry. Now if see, this is a logical diagram of this off order, contain two gates, one XOR gate and AND gates. One output is sum, another output is a carry. Clear? Now see, how do we write a Verilog code in gate level modeling for this off order? Now see, so this is a gate level modeling. So module of order gate having a two inputs A comma B and output sum carry. Clear? So inputs, we are declaring this AB as the input and sum carry as the outputs. This is a port declaration. So how many gates we have? We have two gates, XOR gate and AND gates. Now see, by instantiating this XOR gate, this is instance name G1 having in output a sum and two inputs A comma B. Same way AND gate we have. So now just we instantiate this AND gate and Z2 and output is a carry and the two input A comma B. Like simply we can write a Verilog code in gate level modeling by instantiating these primitives. So how to instantiate gates? So these are the various gates primitives we'll use in the gate level modeling. So now I declare this out in one and two as a void type. So these are the gate names, these are the instance name. So AND gate, and this is a primitive and an instance name G1, and this is the output and inputs in one and in two. So like same way we can instantiate NAND, AND, OR, NOR, XOR, XNOR, buffer, NOT, NAND and like different ways, different gates we are instantiate, okay, to build a different circuits, and we interconnected them by using a wires. Now see, in this case, if you see NAND G7 out in 1 into in 3. How many inputs here? More than two inputs. So this is the three input NAND gates. So if you see in all these instances, the first signal is the output, the remaining are the inputs. We can use, okay, more than two inputs also, like in 1, in 2, in 3. So the first signal is the output, the remaining all are the inputs. So in case of buffer and NOT, we have only one input and one output. So now this is the output one and inputs, output and inputs. So while instantiating these gates, remember the first signal represent the output and the remaining all signals represent the inputs. Now see here, sometimes, okay, we didn't specify the instance name. This is also valid. Without using instance name also, we can instantiate a primitive gates only. So there is no instance name, just output in 1 and in 2. Gate instantiation without instance name, it is also possible. Now see, these are the different gates with additional control signals and buffer and NOT gates also available in Verilog. If you want to build some digital circuit, we need these buffers and NOT if. Now see, these are the buffer if 1 and buffer if 0, NOT gate if 1, NOT if 0. This if 1, if 0 are the control signals. Now corresponding diagrams for this. So now this is the buffer if 1. It acts as a buffer. Buffer means the output equal to input when provide a particular current control signals. Now if control signal is 1, if 1, then output equal to input. So if in this case buffer if 0, the control signal is 0, then the output equal to input. Now here this is a NOT gate, so not the control signal is 1. If 1, then it acts as an actual NOT gate. So here the control signal is 0, then it acts as an actual NOT gate. Output is a complement of input. So the corresponding truth table if we see. So let us consider, I'll explain one buff if 0. So now this is a buff if 0. This is a control signal, this is the data. So if control signal is 0, so buff if 0, if control signal is 0, then this acts as a actual buffer, then output equal to input. Now if control signal is 0, then output is same as the input. So output is 0 when the input is 0. Output is 1 when the input is 1. And if input is X or Z, then output should be unknown X only. Now for example, in this case, if the control signal is 1, then output is high impedance state only, irrespective of input. Same way here, L means low, H means high, L represent the 0 and high represent the 1. So like if you want to analyze these all the circuits, just please pause the video and try to understand by using this truth table. So the output is depends upon its control signals only. Okay, so in this case, if for example control signal is 1, okay, this buff if 0. If control signal is 1, then output is high impedance state only. Already we discussed what is mean logic 0, logic 1, X and Z, why we need this X and Z in Verilog. Already we discussed in detail in data types of Verilog in the initial videos. If not, please visit that video. So array of instances. So we are instantiating repetitive instances. We'll use our single statement to instance multiple gates. Now see here the wire 7 down to 0, output in 1 and in 2. This is an AND gate and this instant name 7 down to 0, out in 1 and in 2. So now this single statement is equivalent to this 8 statements. This is equivalent to the following 8 instantiations. So we can write like this also, or else we can use a single statement like NAND instant name 7 down to 0, output in 1 and in 2. That is the meaning here. This is a gate 0, gate 1, gate 2, gate 3 like that. Okay, so this is a 0th index of this out, 0th index of in 1, 0 index of in 2. Clear? Now see, these instances differ from each other only by indexing of the vector to which they are connected. Clear? So all are same only, right? So in index point of view, those are different. Clear? This is known as a repetitive instances. Now gate delays. So in real circuit, logic gates have delay associated with them. If you want to see, okay, if you want to design a real hardware, it has a number of gates having a propagation delay inbuilt. So how can we model these delays in a Verilog? Okay, so in any real circuit, definitely each and every logic gate has its own propagation delay. Clear? So the signal propagation delay from any gate input to the gate output can be specified using this gate delay. The signal propagation delay from input to the output can be specified by using this delays in Verilog. So in Verilog, the gate delay can be specified in the gate instantiation itself. So for example, if I instantiate AND gate, okay, I need AND gate in my to build my digital circuits. So while instantiating this AND gate, I'll specify the delay associated with that AND gate. Now see, the gate delay declaration specify the time needed to propagate a signal change from the gate input to its output. How much time taken by this, okay, output signal to change, okay, to change. Now see, this is a simple syntax, how do we define the delays in gate level modeling. So now this is a gate primitives and this is a hash and delay. In Verilog, already we discussed, if you want to specify the delays, then we'll use a hash. So hash, delay time and primitive name and connection list. Now see here, example and hash 5. So what is the gate we are instantiating here? AND gate. How much delay it contains? 5 time units delay. So this is instant name and gate 1. So having a one output in 1 and in 2. This is a simple example. Now while instantiating this AND gate, I'll specify how much delay it has. Okay, so the delay associated with AND gate I specified while instantiating this gate. Clear? Now see, a gate delay can be comprised of up to 3 values. So we can maybe specify sometime rise delay or fall delay, turn off delay. Sometimes we specify any 2 or maybe 3 we can specify. Now see what is meant by rise delay. The time taken for the output of a gate to change from some value to a 1 from either 0, x or z. Okay, the time taken for the output of a gate to change from some values to a 1, anything to 1. Okay, that delay known as the rise delay. The fall delay, the time taken for the output of a gate to change from some values to 0 from either 1, x or z. Anything to 0, that delay is known as the fall delay. Turn off delay, so the time taken for the output of a gate to change to z. Z means I impedance, okay, from either 0, 1 or x. Now we see this is a rise delay. So how much time taken by this output, okay, to change to 1 from either x, 0 or z. That delay is known as the rise delay. Same way fall delay means the output of a gate to change from some value to 0, nothing but 1, x or z to 0. That delay is known as the fall delay. So here in case of turn off delay, so now that gate output to change to z, either from x, 0, 1, okay, anything, either 0, 1, x to z. So these are the 3 delays we can specify, and these 3 delays can be specified while instantiating the gate itself, right? So delay specification time. How many ways we can specify the delays? Are 1 delay, 2 delays, or 3 delays, like a rise time, fall delay, or maybe 3 of, okay, rise time, fall, turn off delays. Like see first, if I specify only 1 delay, #3. So delay 3 for all transitions. So all 3 transitions follow this delay 3. Now see 2 delays, #3, 4. The rise is 3 and fall is 4. So rise delay is the 3 and fall delay is the 4. If you specify only 1 delay, #3, okay, this is delay 3 for all transition. Okay, that may be 0 to 1 or 1 to 0 or something to x. All transitions, okay, followed this delay. Now here 2 delays means #3, 4. So these are 3 is the rise delay, 4, fall delay. So we can specify the 3 delays also, like #3, 4, 5. So what is the meaning here? So rise delay is the 3, fall delay is the 4, and turn off delay is the 5. Now see this is the example. So R #3, this is the instant name O1 and outputs Y1 and the 2 inputs I1, I2. So now I instantiate OR gate, so with a delay of 3. So now is the 1 delay representation. So now it is delay is 3 for all transition. If any transition from, okay, anything to any, or 0 to 1 or 1 to 0 or 0, 1, x to z, anything, any transition, okay, it occurs after delay of 3 time units only. So now, so R #3, 4, O2, Y2, I1, I2. What is the meaning here? 3 represent only rise delay. Okay, here 4 represent the fall delay. So rise delay means anything to 1. Okay, so here fall delay means anything to 0, right? That is known as a fall delay. Now buffer if 1, #3, 4, 5. So this instant name, output and input and control signals. So what is the 3 here? Rise delay, 4 fall delay, 5 turn off delay. So we'll see some example. Now I'll take this simple example, and #5, 10, G1 out I1, I2. Just I'll take this example. So here I'm specifying 2 delays. What is this 5 here? Rise delay. What is the 10 is fall delay. Now see, rise delay is the 5 and fall delay is the 10. Now see in this circuit here. So now this is a HAND gate having 2 inputs I1, I2. Output is out. Okay. Now, so now till this point, now see till this 30, both inputs are 0. Both inputs are 0. Then in case of AND gate, both inputs are 0, output is 0. Now till 30, both inputs are 0, then output also 0. Now at the time instant 30, at the timestamp 30, what happened? That inputs both I1 becomes 1 and I2 also becomes 1. Both are changed, okay, from 0 to 1. So now at this time instant, inputs for this AND gate is both are 1. Both are 1. So both are 1 means for AND gate, the output also 1. But what is that here delay specifying? The rise delay is 5 and fall delay is 10. So what is mean rise delay? Anything changes to the 1. Okay, the output is changed from anything, either 0, x, z to 1. That is known as the rise delay. So now if both are 1, then AND gate output is 1. Okay, but we are specifying the rise delay is the 5. After 5 time units delay only, that output becomes 1. So now this is called rise delay. Okay, now after 5 units of time delay only, the output is changed from 0 to 1. Same way, for example, if you see the time instant at 60. So now one of the input is a 0 for this AND gate. So another input is 1 only. So one input is 0, another input is 1. For in this case, the AND gate output is 0. But so now till now the output is 1. So output becomes 0 at the time instant 70 only, not at 60. Because the what is the fall delay here? I specified while instantiating this AND gate, it is a 10 time units. So whenever the output is changed from anything to the 0, so it takes 10 time units delay. Now if you want to change this output from 1 to 0, okay, it takes 10 time units of delay to reach. Okay, so now here fall delay is at 10, so the output is updated, okay, after 10 time units only, because it is a fall delay. The output is changed from 1 to 0 after 10 time units delay only. Now not at 60, the output changed at 70. I hope you understand, okay, what is meant delay, how to specify these delays, okay, while instantiating the gates. So we have another additional level of control for each type of delay. So Verilog provides an additional level of control for each type of delay, like a min max typical delay. So this main typical max values are used to model devices whose delays varies with a minimum and a maximum range. We can specify the minimum and maximum range of these delays while instantiating the gates. So what is the min value here? The min value is the minimum delay value that the designer expect the gate to have. This gate has at least this much of delay, and a typical value is a typical delay value that the designer expect the gate to have. So this is a typical delay of that gate. So the maximum value is the maximum delay value the designer expected to have. This is a maximum delay that gate has, right? Now if I instantiate like this, and hash 2 is to 3 is to 4, 3 is to 4 is to 5, and 4 is to 5 is to 6, A3 out I1 I2. So now this is the delays are specified in terms of min max typical. Okay, this is the minimum rise delay 2, typical rise delay is the 3, okay, the maximum rise delay is 4, like a fall turn up delay. We can specify the rise, fall and turn up delay, as well as also we can specify the minimum and maximum range also. Okay, so this is another additional level of control for each type of delays. So I'll explain, okay, one example. Here, take this circuits having a 2 gates, one is AND gate, one is OR gate. So now having a 3 input A comma B comma C and 1 output. Okay, one intermediate signal we use it to interconnect these 2 gates. Now out is equal A and B plus Z. So what is the gate delay associated with this AND gate is 5. So the delay associated with the OR gate is the 4. Now see, how do I write a Verilog code for this now? Simply the module name something, right, is a assume that, okay, having a output and inputs out A comma B comma C. You should declare what are the signals are output, what are the signals are input. Now this out is output. So you should declare, okay, whether it is input or output. This ABC is an input. Clear? So now this is a wire E. Already we discussed, okay, reg and wire type in detail in initial videos. Okay, so where should I use wire, where should I use a reg? Okay, what is the purpose of this reg and wire in hardware correction point of view? If not, please visit that video, then you'll get an idea. So I'll use a one intermediate signal E to connect these 2 gates. So wire E. So now I instantiate this AND gate, and so the delay associated with the AND gate is hash 5 A1. So this is an instant name. E is the output for this AND gate and 2 inputs A comma B. Same way, now I instantiate OR gate. Okay, it has a delay hash 4. Okay, this is a 4 time units delay and instant name O1, and this output having a 2 inputs. One is the C, another input is output of this AND gate, the E. So E comma C. This is a simple way we can write, okay, gate level Verilog code for this circuits. Now this is a test bench to test this one. Okay, so this digital circuit. So this I will discuss in detail about how to write a test bench in Verilog. Just for example point of view, just see how do I use, okay, test bench. So first module, this module name. Anyway, remember as of now just inputs are declared as a reg type and outputs declared as a void types. Okay, reg a comma b comma c and wire output. Now I want to test this model, so I should instantiate this in my test bench. So now instantiate d is my module name and d1 instant name. I instantiate like this. So we'll discuss in detail about how to write a test bench in Verilog in the coming lectures. So as of now, just how to write, how to generate a stimulus to test this. Use this code. Okay, initial, a begin, and end model. So now here is initial and always are procedure blocks. The statements written in the initial are executed one by one. These are all sequential statements. Okay, it execute one after another in the order which we write. So now a equal to 0, b equal to 0, c equal to 0. After time minutes, 10 time delay, I'll change all values as a 1. And after 10 time minutes delay, then a become 1. Okay, as b equal to 0 and c equal to 0, like that I'll change. After 20 time minutes, I'll finish this simulation. So don't worry, I'll explain in detail about test bench, how to write these test benches in coming lectures, right? So now see, now this is simple waveform. So a, b, c. Now a, b and c are 0. Now here we have AND gate output E and actual output of the circuit is out. Now if A, B, C are 0, okay, now what is the output of this AND gate? If A, B both are 0, then E also 0. Now see, after, if for example at the at time equal to 0, A equal to 0, B equal to 0. Now after 5 time minutes of delay only, that actual AND gate output becomes 0. Until that we don't know, okay. So now the output is 0 only at 5 time minutes of delay, because the delay associated with the AND gate is 5. Now E is equal to 0 at 5. Same way, now see, if you observe, what is the delay here? 5 plus 4, 9. Till 9 we won't get a valid output. Now see here, at this moment, so A is changed from 0 to 1 and B also changed to 0 to 1. Now if both are 1 for this AND gate, that output equal to 1. But what is the delay associated with this AND gate? Is 5 time minutes delay. So if both are 1, output equal to 1. Okay, so this AND gate, but it reflect only after 5 time minutes of delay. Even though input changes at time minutes 10, okay, that output will be reflected at 15th time minute only, because the delay is 5 here. So the output becomes 1, correspond to these two input at 15th time minutes only. Now see, now here, so in this case at time minutes 10, what is that C? C is 0 to 1. Okay, C is 1. What about E? E is also 0. Now anyway, this is OR gate. If one input is 1, then output equal to 1. Anyway, we are C equal to 0 to 1. So C becomes 1 at time it's 10. That output should 1 for this OR gate. But how much delay? It required 4 time minutes delay to get a valid output. Now, even though C is the output equal to 1 here, but it takes 4 time minutes of delay, because the OR gate delay is 4. The output updated at a 14th time minute delay. Clear? So I think by this example you will get an idea of we are getting outputs. Now see here, see another example. Here A is 1, B is 1, okay, but B becomes 0 at the time it's 20. See, so now one input is 1, another input is 0. So for this AND gate, that output should be 0. That the output should be updated after 5 units of time delay, because the input is 1, one input is 1, another input is 0. For this AND gate, output is 0. It should be updated. In ideal case, if 0 delay means the output should be 1, the output should be 0, sorry, at 20 time minutes delay only. But it takes 5 time minutes delay to get output 0, like that. Clear? I hope you understand this example. So in this video, I explain what is mean gate level modeling. So how to instantiate various gates, known as the basic gates, known as the primitives. Clear? How to specify the delays associated with that gates, either in 1 delay specification, 2 delay specification, 3 delay specification, and also right min, typical, max type also. I hope you understand how to write okay Verilog code in gate level modeling, okay, for various digital circuits. Thank you very much.